All right, today we're talking about some probability simulations. Now, this is a little bit different from our probability distributions, but we're going to be talking a lot today about the difference between theoretical and experimental probability. Theoretical is what should happen. When you toss a coin, you're going to go ahead and have theoretically a 50-50 chance. However, if I start flipping the coin, and after two tosses I should get one heads, one tails, theoretically. But if I do that, do I always? I can get two heads or I can get two tails. That's the difference between theoretical and experimental. Experimental is where you actually try to go out and you prove it. You try to draw cards, or you try to flip the coin, or do a spinner, or whatever it is. It's the practical application of it. Theoretically is what should happen all the time in the long run. And so that difference has to be discussed. And that's a little bit of what we're dealing with today. We're going to take a look at some different things theoretically, and what if we actually did some experiments on it. So Miguel shot 50 free throws in the gym and found that his experimental probability of making a free throw was 40%. It's not necessarily very good. How many free throws did he make? So by shooting that 50, it comes out of the theoretical and becomes an experimental. We know what happens. Maybe he thought he was going to shoot 50%, but in reality, he only shot 40. Now, how many did he make? Well, that's actually pretty easy. Miguel's experimental probability was 40%, so we take our 40% times how many. It's also sometimes called the expected value. So 40% times 50, again, 40% is 0.40, is 20, so he made 20 out of his 50 free throws. Nancy is serving for volleyball. She served 80 balls and found that she was keeping 60% of them in bounds. So how many serves? Again, 60 times 80 is 48. So she had 48 serves in bounds. A pharmaceutical company performs 3 clinical studies to test the effectiveness of a new medication. Each study is 100 volunteers, and the results are here. Here's your expected rate, or what would have been their theoretical probability, is 70% of the people were going to improve. However, when they actually tested it, not all of that happened. 61 improved, 39 didn't. 74 and 25. Even one got worse. 67, 33, and 0. So they actually tried, and even though they were expecting 70, it didn't quite work out that way. So what it is, the experimental probability, we're going to have to go ahead. Remember, each of these are 100 each. So we're going to go ahead and put these together and find out what the total experimental probability for the drug was. So 39, 25, and 33 are 97 out of 300. So dividing it by 3, we get, that was no improvement. They wanted no improvement. That showed no improvement. So we're looking at these 3, not the top 3. My mistake. So 39, 25, and 33. Put those together. So about 32% showed no improvement. Here's a different study. They were expecting 80%, and the first one went really well, and then those became underneath. And again, we can find out the probability that it went ahead and helped. So we have 63, 75, and 78. There's 236, and there was 3 of those, and they were all the same. They were all based out of 100, so we can just go ahead and divide by 3 for 79%. In the last 30 days, Bobbie's older brother had given her a ride to school 5 times. What would you use to simulate whether or not Bobbie's brother could give her a ride? So that's 5 out of 30, or 1 in 6 days. So what is something that can happen 1 in 6 days that we could use to simulate it? Like a die. Rolling a die has 6 sides. You could use one side, the 6-sided. If I roll a 6, it meant that Bobbie gave her a ride. Just something to simulate the possibilities. describe a way to simulate over the next 20 days, it would just be taking that die and rolling it 20 times. And we could go ahead and see whether or not and guess how many times. That's one way to do the experiment. This is our theoretical probability. This would be our experimental when we actually do rolling the die. In the last 52 days, it rained 4 times. What could we use to simulate whether or not the rain on a given day? Well, a deck of cards is 52, so that's a really easy thing to go ahead and do. And maybe since it rained 4 times, we can just go ahead the 4 2s or the 4 3s and use that as you pull out a deck card. So here, down here at the bottom, a way to do it for 15 would be to draw out 15 cards and all the aces or all these other ones. Flipping a heads is a raining day. That's a 50-50. That's not what we have. We have 4 out of 52. That's a different probability. So we can't use that even though it's 15 times for the 15 days. We can't do things that are different probability. You got to keep it the same. So since we have 52, 4 out of the 52 would be like aces. Allie raises purebred dogs. Dog expecting a litter of 4 puppies. What's the probability or the most likely mix of male and female? The male and female possibilities are 1/2. So we would have to go ahead and do something that's a 1 to 2. So we could very easily do coins, or we could do dice 1 to 3 and 4, 5, 6. Any of these kind of probabilities you could go ahead and do as long as we keep the probability the same, and we could then simulate it. There are a total of 16 different possibilities. So another way we could possibly do it is maybe a spinner with 16 different spots. Mark each one for each and then spin it and see what the different possibilities, outcomes are. So there's a lot of different ways that we can go ahead and do this. Again, we're back here with the 4 puppies. What's the probability that there will be 4 females? Well, 4 females, that's only a 1 possibility that it comes out to. So it's only 1 out of that 16. There's only one possibility that has all 4 tails if we were flipping the coins. So now we actually have some data, maybe from a veterinarian or something like that. And here's the experiment over the last several occurrences. 4 females 3 times, 3 and 1 male is 13 times, 2 and 2 was 18, and this is probably expected. 0 and 4 males 4 times. But now this is an experiment, and it has little different probability than what we just got done doing. So we have 3 out of the total amount. And there was 50 trials, so 3 out of that 50 is just 6%, which is a little bit different than what our actual probability is. 1 out of 16 is a little bit different than just a straight 6%. They're close, but you can see as you try an experiment, it doesn't always fit exactly. All right, the Cleveland Indians and White Sox play each other 5 times in the next week. Let's say the probability of winning is half. They're just as good at each other. Find out what the most likely mix of wins and losses. So how could we possibly simulate this? Well, if there's 50-50, what thing is 50-50? Flipping a coin, you could go ahead and do 5 times because that's 50-50. Rolling a 6-sided die, you actually probably could if you do 1 to 3 and 4, 5, and 6, and you roll it 5 times. A deck of cards, black versus red cards. A spinner with 4 equal sections. These 2 represent a White Sox win. These 2 represent a Cleveland win. So actually all of them could work if you did them all 5 times. All right, what's the theoretical that the Indians would win 3 games? So we have to go ahead and find out the different possibilities. So I created a factor tree here. So the first game, the White Sox could win or the Indians could win. And then the White Sox or Indians and just kept going. Now there's a total of 32 different outcomes here. 1 was 5 White Sox wins, 1 was 5 Indians. 4 White Sox and 1 Indian was 5 of them. We found that by a White Sox win, and then an Indian, or any kind of combination. There was 5 of them, and 10 of them this way, and so on and so forth. So when we're looking for an Indians to win 3 games, that's this probability here. There's 10 out of 32, or 5 out of 16, or 31%. So that's the theoretical probability. Let's find out what actually happened. In the last 35-game series between the two teams, these were the outcomes. The Indians won every game twice. The White Sox won every game once. In combinations here, and so Indians win 3 times, White Sox 2. That was 10. 10 out of 30, or 1/3, or 33%, which is different than that 31%. That's what was to be expected, but in reality, when we did the experiment, it was 33%. So we know that it's just a little bit different. And that's what I have for you today.